Welcome to aminacademy.com. In differentiation, let us discuss about increasing and decreasing functions. Let us discuss about strictly increasing functions. Look at this figure. Here, y equal to f of x, the curve is drawn. A function f of x is said to be a strictly increasing function on an interval a and b if x1 is lesser than x2, then f of x1 is lesser than f of x2 for all x1 comma x2, the element of the intervals a and b, which means in between the limits here a and b is the open interval. In between we are taking a value of x1 and x2, x3, like lot of values you can take. In that, suppose if x1 is lesser than x2, then substitute these values in a function y equal to f of x, then we'll get, if we get f of x1 is lesser than f of x2, then we can say this function is strictly increasing functions. Means whatever value in between the interval if we give, if the values are increasing manner, then the value of function, that is y equal to f of x, also increasing. So this function is called strictly increasing function. Now let us do an example regarding this concept. Show that f of x equal x squared plus 2 is strictly increasing function on an interval 0 to infinity. Let x1 and x2 is an element of 0 to infinity, the interval, such that you can say if x1 is lesser than x2, then x1 is lesser than x2, which gives x1 square is also lesser than x2 square, and x1 is lesser than x2, then we can say if we multiply both, that is x1 into x2 is also lesser than x2 square. For the above conditions, we get if x1 is lesser than x2, which gives x1 square is lesser than x2 square. Further, it gives f of x1 square is lesser than f of x2 square. Thus, we can say x1 is lesser than x2, which gives f of x1 is lesser than f of x2 for all x1 comma x2, which is an element of the interval 0 to infinity. Hence we can arrive the answer, that is f of x is strictly increasing function.